Hey, this is Mr. Ward, and I'm gonna doing a practice video for you on rotations. And your job to do is to try these, and pause the video once there's one here, and then you can unpause it and compare what you came up with to what I came up with. So you should take a look at the points for this triangle. It's going to have a center of rotation of 0, 0 right there. And your job is first going to be to rotate the object 90 degrees clockwise around the center of rotation at the origin. So see if you can come up with what the new coordinates are going to be for this new triangle when it is rotated 90 degrees around the center of rotation at the origin. So you should pause the video, and when you're done, or if you get really stuck, you can come back and see what I did. Okay, so I'm assuming you paused the video, and I'm going to go ahead and copy my original triangle points. And since I'm going 90 degrees around the center of rotation at the origin, this point here, which is in quadrant 1, is going to end up in quadrant 4. Okay, so the first thing I know I'm going to be switching the x's and y's. Then it's just a question of figuring out which one of those is going to change signs. So I'm going to do this a little different from just following the rules. I'm going to think this through. So I know that I'm switching x's and y's. So this is I'm going to say -2, 5, and get rid of that extra stuff. Okay, so I'm going from this 5, -2 point. Let's consider this one in particular. I'm supposed to end up here, not up there. So when I switched the two values, I switched the x and the y, I ended up with the wrong sign for one of them. So I need to actually end up in quadrant 3, where both x and y are going to be negative. So notice when I switch them, the negative, there's a negative, and that's the x, but the 5, the y, the new y is positive. So now that helps remind me, oh, it's the y, the new y that's going to change signs. So now I've changed the sign for the new y. And let's keep going. So now I just know that I'm going to be switching the x's and y's, and the new y is going to change signs. So that's in the right place. So this 2, 3 became 3, -2. So, and that's makes sense. It's gone 90 degrees clockwise from quadrant 1 to quadrant 4, and where y is negative and x is positive. Now I have to rotate the -4, -1. So that's going to end up being -1. And instead of -4, I had to change the sign of -4 to +4. And then I, of course, have to do this last one. So let's just copy pasta this. And now I have my rotated triangle. It's rotated 90 degrees clockwise around the origin. I switched x's and y's, and the new y changed its sign. And there we go. We've rotated it. Now, let's go ahead and have you try rotating the original object 90 degrees counterclockwise around the center of origin. And you should pause the video, of course. And I'm going to, while you're thinking about pausing the video and then getting your work done to figure out what the new coordinates are going to be, I'll copy the triangle, my original triangle, my object, here so that I can monkey around with the x's and y's. So I'm going to assume you have paused the video, and you'll remember from the last one, we switched the x's and y's, and the y's change sign. Now going counterclockwise, you're going to still switch the x's and y's, but instead of the y changing sign, the new x is going to change signs. So I'm going to take this here, this -2. I'm going to put it here, -2, 5. And that -2, it's the x that's changing sign here, so that becomes +2. So I went from this point here, 5, -2, I rotated 90 degrees in this direction. Okay, and so I end up right here in quadrant 1 where both x and y are positive, and that's what I ended up with. Here I'm going to go 90 degrees counterclockwise. I'm going to end up in quadrant 2, so x and y will change places. And then in quadrant 2, x is always negative. So, and once again, it's the x that changed signs. So here I'm going to switch from -4, -1 to -1, -4, and the x changes sign. And I'll just copy this first point into the last one. And I just switched all my x's and y's, and the new x changed its sign. And I'll go ahead and give the triangle sides by opening up this and hitting the line tool. And there we go. I've rotated 90 degrees counterclockwise. All right, I'm going to turn off the previous one so you can see it a little better. So we've rotated this whole thing 90 degrees around counterclockwise. And now I'm going to turn that one off, and we will rotate this triangle 180 degrees around the origin. It does not matter which direction. So copy pasta, my original triangle. You should try and figure out, what the new XY points are going to be for our 180 degree rotation around the center of rotation at the origin. So assuming you have paused the video and you have done that, I'm going to go ahead and start changing the points. So all you have to do for rotating 180 degrees is change the signs of all the x's and y's. So if this x becomes -5, that becomes +2. This becomes -2 and -3. And this becomes +4 and +1. And this becomes, and go back and do this one, -5 and +2. And I have rotated this 180 degrees around center of rotation at the origin. I give it its lines, and there it is. All of these points have gone all the way around. Okay. We're going to do one more, and this last one is to rotate the object 270 degrees counterclockwise. So I'll turn this one off. Okay, so I'm going to rotate this object 270 degrees. So that means I'm going 1, 2, 3 quadrants. Each quadrant is 90 degrees. Now, if I'm going 3 quadrants, that means counterclockwise, that means I'm actually going 1 quadrant clockwise. So that really is just going to end up being, well, I should have let you pause the video. I'm going to let you work out what that's going to be. So I'm going to stop talking and let you pause the video and see if you can come up with what the points are going to be. So assuming you did pause it, you probably are realizing from the things I just said that a 270 degree counterclockwise rotation is just the same as a 90 degree clockwise rotation. So 90 degree clockwise rotation, if I move from here to here, basically all my x's and y's are going to change positions. Okay, so that's going to end up being -2, 5, but my x is going to actually change signs. Did I do that right? No, I'm sorry. Clockwise, the y is going to change signs. So this point went to here. This is the point that I was thinking of just now. So 3, 2. And so the 2 changes signs. But all the y's are changing signs. And all the x's are staying the same. Okay, so we just did, all we had to do was a 90 degree rotation clockwise to do a 270 degree rotation counterclockwise. If you wanted to, you could just do 3 90-degree rotations, or you do a 180-degree rotation and then another 90-degree rotation. But I think that's more work than you need to do. I think a little bit of analysis gets you what you need. Okay, I'm going to turn all of these on, and I'm going to show you that the points truly did rotate around the origin. Okay, so we got nice little 4 triangles. And the way I'm going to do that is I'm going to make a circle equation with a radius that is given to me by, basically I'm making a right triangle here that has a side of 2 and a side of 3. So the hypotenuse here is going to be the square of 2 plus the square root of 3, and we'll get the square root of that. But since a circle is basically x squared plus y squared equals radius squared, I can just square that back and call it 2 squared plus 3 squared. That'll make more sense once you've learned more about circle graphing. You don't need to know how this works right now, but you can probably figure it out. So I'm going to start off with this 2, 3 point, and what you will see is this point will be on the same circle here, 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 and here. Okay, they will all be on the same circle. I'm going to say 2 squared plus 3 squared. I need to put an equal sign in there instead of a plus. And there, I've made a circle that touches this point, this point, this point, this point. So it's rotated all the way around. Now I'll do another circle. And this one, I'm going to take this point here, 2, 5. And it'll be 2 squared plus 5 squared. And you'll see that that circle touches all of those as well. They've all rotated around a circle. And one more circle. In this case, let's see, it's this point that I need to connect, 4, 1. So it's going to be 1 squared, which is just 1, and 4 squared. And so that one works as well. So I've demonstrated that I truly have rotated these around a center of origin by using circles. All right, I'm going to go ahead and stop, and I hope that this has helped give you a little more confidence with rotations. And let me know if you need more practice. There is, of course, more practice available to you in the list of resources that I have provided.